Hello everyone. Welcome to our session on DIT algorithm. In our today's session, we are going to learn how to perform DFT, 8-point DFT using DIT algorithm for any given input sequence x of n. So x of n is given by 2 for n is equal to 0. It is given by 1 for n is equal to 1. It is given by 2 for n is equal to 2. 1 for n is equal to 3. 1 for n is equal to 4. 2 for n is equal to 5. 1 for n is equal to 6 and 2 for n is equal to 7. Okay, so in order to solve this, step number 1 is basically we need to represent the given inputs in bit reversal order. So how do we represent the given input in bit reversal order? So represent the given input down the line like this: x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So its value is 2, 1, 2, 1, 1, 2, 1 and 2. Okay, the bit equivalent for 0 is 0, 0, 0. Bit equivalent for 1 is 0, 0, 1. Similarly for 2 it is 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1 respectively. If I reverse this bit 0, 0, 0, it is going to be 0, 0, 0 only. So this is equivalent to x of 0. So if I reverse this bit, it is going to be 1, 0, 0. So 1, 0, 0 is nothing but x of 4, bit equivalent to 4. So if I reverse this remains as 0, 1, 0 only. Therefore, it is equivalent to x of 2. If I reverse this bit, it is 1, 1, 0. So 1, 1, 0 is equivalent to x of 6. If I reverse this is going to be 0, 0, 1. 0, 0, 1 is going to be x of 1. If I reverse this is 1, 0, 1 only. Therefore, it is x of 2. Sorry, x of 5. If I reverse this is going to be 0, 1, 1. So 0, 1, 1, this is going to be x of 3. And if I reverse this is going to be 1, 1, 1 and it is equivalent to x of 7. Hence, the bit reversal order for any given 8 input is found to be x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. Its equivalent value as per the given questions are 2, 1, 2, 1, 1, 2, 1 and 2. So after representing the inputs in bit reversal order, we need to know the twiddle factor values to further solve the problem. So twiddle factor are represented by w suffix 8 power 0, its value is 1. W suffix 8 power 1, its value is 0.707 minus j 0.707. W suffix 8 power 2 is given by minus j. W suffix 8 power 3 is given by minus 0.707 minus j 0.707. So after writing these twiddle factor values, so we need to find 8-point DFT using DIT algorithm. So we need to draw the structure of DIT algorithm. So as we have 8 input data, so we need to draw 8 horizontal lines like this: 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so this 8-point DFT have 3 stages. Along the first stage, line 1 is connected to line 2, line 2 is connected to line 1 like this. Similarly, 3 is connected to 4 and 4 is connected to 3. 5 is connected to 6, 6 is connected to 5, 7 is connected to 8 and 8 is connected to 7. So this is how the connection works with as far as stage 1. Similarly, for stage 2, 1 is connected to 3, 2 is connected to 4, 3 is connected to 1 and 4 is connected to 2. Similarly, 5 is connected to 7, 6 is connected to 8, 7 is connected to 5 and 8 is connected to 6. So this is with respect to stage 2. Similarly, for stage 3, 1 is connected to 5, 2 is connected to 6, 3 is connected to 7, 4 is connected to 8 and 5 is connected connected to 1, 6 is connected to 2, 7 is connected to 3 and 8 is connected to 4. So this is with respect to drawing the skeleton. So we need to know how to draw the skeleton. So after drawing the skeleton, we need to place the inputs in bit reversal order. So according to the bit reversal order, so bit reversal order is given by x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. Whose equivalent values are x of 0 is given by 2, 1, 2, 1, 1, 2, 1 and 2. So after representing all these inputs, we need to mark the multipliers. The multipliers are represented by, so for the stage 1, so multiplier is drawn along the second line and its equivalent value is minus 1. So along the fourth line whose value is minus 1, along the sixth line whose value is minus 1 and along the eighth line whose value is minus 1. Similarly, for stage 2, so it is drawn along the third line, value is minus 1, along the fourth line and its value is minus 1. Similarly, along the seventh line whose value is minus 1 and along the eighth line it is minus 1. In stage 3, it is drawn along the fifth line, sixth line, seventh line and along the eighth line. So these are the multipliers. So after drawing the multiplier, we need to represent the twiddle factor. So twiddle factor is always represented before the multiplier. So for stage 1, so twiddle factor values are w suffix 8 bar 0. So it is placed before the multiplier everywhere. So value of twiddle factor for stage 1 is w suffix 8 bar 0. Similarly, for stage 2, before the multiplier, I am placing the twiddle factor value whose values are w suffix 8 bar 0 and w suffix 8 bar 2. Similarly, at this point, it is w suffix 8 bar 0 and w suffix 8 bar 2. Similarly, for stage 3, the values of twiddle factor are w suffix 8 bar 0, 8 bar 1, 8 bar 2 and w suffix 8 bar 3. So after representing the twiddle factor values, we need to go ahead and solving the problem. Okay. So for solving the problem, I need to represent the inputs along stage 1. So the input along this point is the line that is coming along this particular point and its value is 2. So for this particular point, the input value is going to be 2. When we look at this particular point, the value is 1 and in the same line, we have a twiddle factor multiplied w suffix 8 bar 0. We know the value of this twiddle factor is 1. So you need to multiply this 1 with 1. So 1 into 1 is 1. Hence, the value at this particular point is going to be 1. So like that, we are going to mark the inputs for stage 1. So for stage 1, the first input is 2. The second input is 1 into 1. So here twiddle factor value is 1. So 1 into 1 is 1. Therefore, the input value is 1 here. 2 is my next input. Fourth input is 1 into the twiddle factor value whose value is 1 here. Therefore, 1 into 1 is 1. Now my next input is 1 coming directly. Twiddle factor value is 1 here. So when you multiply 2 with 1, the value is 2. Therefore, this input value is going to be 2. So 1 is coming directly. Therefore, this input is 1. And when we come to this particular point, twiddle factor value is 2. So 2 into 1, so it is 2. So this is with respect to the input. Okay. So after marking the input, we need to find the output of stage 1. So the output value of stage 1. So how do we find the output at this particular point? So when we look at this particular point is connected by this line and it is connected by this line. The value that is transferring through this particular line is 2. So it is 2 plus value that is coming along this particular line is 1. So it is 2 plus 1. So 2 plus 1, it is 3. So therefore, the value at that particular point is 3. So I am changing the color so for better understanding. So it is 2 plus 1. So the value at this particular point is 3. Similarly, when we check for this point, okay, so find the value at this point. So this point is connected by this line and it is connected by this line. So at this line, I have 2 plus, I have one input here multiplied by the multiplier, which is -1. So 1 into -1 is -1. So I repeat it again for better understanding. So I wanted to find the value at this particular point. So this particular point is connected by this line and it is connected by this line. So the value that is coming through this line is 2. So 2 plus, along this line, my input is 1. I have a multiplier here also. So I need to multiply this 1 with -1. 1 into -1 is -1. So 2 plus -1. So 2 plus -1, therefore my value at this particular point is going to be 1. Hope this is clear. Similarly, the value at this particular point is 2. 2 plus 1, so it is 3. The value at this particular point is 2 plus 1 into -1, -1. So 2 minus 1, therefore the value at this point is 1. So to find the value, output value at this particular point is, it is 1 plus 2, therefore it is 3. Similarly, finding out the value at this point, it is 1 plus 2 into -1. So 2 into -1 is -2. So 1 minus 2, therefore the value is -1. Similarly, to find the value at this particular point, it is 1 plus 2, it is 3. Similarly, it is 1 minus 2, therefore the value at this point is -1. Okay, so we have found the output across stage 1. So now we need to mark the input along stage 2. So how do we find the input along stage 2? So what is the input at this point? Okay, so 3 is directly connected here. So the input at this particular point is 3. Similarly, 1 is directly connected here. Input at this particular point is 1. If you see here, 3 is multiplied with the fiddle factor value, which is W suffix 8 power 0, whose value is 1. So 3 into 1. So you need to multiply the equivalent fiddle factor value here. So 3 into 1, therefore it is 3. If you look at this point, it is 1 into the value of the twiddle factor. So W suffix 8 power 0 is minus j. So 1 into minus j is minus j. Therefore, input at this particular point is minus j. Okay, so we need to represent inputs like this. So the first input, 3 is coming directly, therefore it is 3. 1 is coming directly, therefore it is 1. Here we have 3 into, the value of this twiddle factor is 1. So 3 into 1, so it is 3. The value of this twiddle factor is minus j. So 1 into minus j, so it is minus j. Similarly, 3 is coming directly here, so it is 3. 1 is coming directly, so it is 1. So W suffix 8 power 0 is 1. So 3 into 1, therefore it is 3. W suffix 8 power 2 is minus j. Minus 1 into minus j is plus j. So this is the input across stage 2. Now we need to find the output of stage 2. So I need to find the output at this point. So this point is connected by this line whose input is 3, and it is connected by this line whose input is 3 again. So 3 plus 3 is 6. The value at this particular point is 6. So I'm changing the colors. So 3 plus 3 is 6. So the value at this particular point is 6. Okay, and we have 1 minus j. So the value at this point is 1 minus j. So we have 3 plus 3 into minus 1. So which is minus 3. 3 minus 3 is 0. At this particular point, it is 1 plus minus j into minus 1. So it is 1 plus j. Hope it is clear. Similarly, we find the next 4 values. It is 6, 1 plus j, 0, minus 1, minus j. So this is the value across stage 2. Okay. So this is the value across stage 2. Okay. So now we need to find the value input of stage 3. So input of stage 3. So input of stage 3, at this point 6 is coming directly here. Therefore, the input at this particular point is 6. Here it is 1 minus j, 0, 1 plus j. Now we have 6. It is multiplied with the twiddle factor value. Its value is 1. So 6 into 1 is 6. Okay. So W suffix 8 power 1 is given by 0.707 minus j 0.707. So you need to multiply minus 1 plus j with 0.707 minus j 0.707. So this I'm representing it as A and I'm writing A here because we don't have sufficient space to write it over there. Similarly, the value at this particular point for w suffix 8 power 0, the value is minus j. So 0 into anything is going to be 0. So the input value at this particular point is 0. Similarly, the value at this particular point, it is minus 1 minus j into the twiddle factor value w suffix 8 power 3. So minus 1 minus j w suffix 8 power 3 is given by minus 0.707 minus j 0.707. So whose value is b? Okay, I'm writing it as b. So I'm writing b here because we don't have space to mention it clearly there. Now, having represented the inputs of stage 3, we need to find out finally with the output of stage 3. So the output of stage 3, the output at this particular point. So this particular point comes via this line and the input is 6 and it is connected through this line whose input is 6. So 6 plus 6 is going to be 12. So the value at that point is going to be 12. So the value at this particular point is going to be 12. So I'm marking 12 here. Similarly, to mark the value at this particular point, so this input comes from this line and A. Okay, so the value at this particular point, I'm writing it below down the line here. So it is 1 minus j plus, what is A? A is minus 1 plus j into 0.707 minus j 0.707. Okay, so if we simplify this value, this is going to be 1 plus j 0.414. So the value at this particular point is 1 plus j 0.414. So 0.414. Similarly, we need to find out the value at this point. So the value at this point, it is 0 plus 0. It is going to be 0. The value at this point, it is 1 plus j plus b. Okay. So 1 plus j plus b is minus 1 minus j. So we have b value here. Okay. So I'm writing it directly here. 1 plus j plus minus 1 minus j into 0.707 minus j 0.707. Okay, upon simplification, the value that we obtain here is, so I'm writing it here. So the value is, simplify that and you'll get the value 1 plus j 2.414. Okay, so the value at this particular point is 6 minus 6, 6. Okay, so the value at this particular point, it is going to be 0 because we have 6 into multiplier, 6 into minus 1 is minus 6, so 6 minus 6 is 0. Similarly, if we find the value at this particular point is 1 minus j 2.414. Here you will have the 0 and it is 1 minus j 0.414. So this is how we need to solve the problem using DIT method. So finding the DFT using DIT method. So finally, x of k is given by 12, 1 plus j 0.414, 0, 1 plus j 2.414, 0, 1 minus j 2.414, 0, 1 minus j 0.414. Hope this problem is clear. Thank you. Thanks.